go. My laptop is lagging out.
Yeah, I could
Okay.
see it from the center.
Is it? Can you check if the stream is started? I think it is. Oh
Yeah,
yeah,
let
I
me
think
check.
we're good. We're good. We're good.
Okay.
Okay. Hi everyone. I'm Neil Mitchell from FTC Team 14481 Don't Blink, and today we're going to be talking all about subsystem integration. And that might sound scary at first, but at the high level, all it is just transfers. So that includes handoffs, buckets, no transfer, and how you can utilize two mechanisms and ultimately make them work together. So today we're joined by Rishi. If you want to introduce yourself.
Hello, I'm Rishi. I'm on Don't Blink. I'm a programmer.
Yeah,
I've been doing Rookie Rescue for a while now, and I'm excited to jump into this topic today as
yeah,
well. Right? Yeah, I think today will be fun. I think it's one of the most complicated topics that we'll be talking about in recent weeks. It's definitely a step up for some rookie teams if they want to take their robot to the next level, right?
yeah, for
Well, this is
sure.
a really important topic. So yeah,
Yeah.
let's get started.
Um, so I think Rishi's insight will be really important too for the programming rookies out there to understand, okay, how can I make it so that this happens at the exact time, and how can I make it so that it all works together cohesively and is obviously as fast as can be. So I think we should first get started off with some of the more basic mechanisms. So lots of teams this year, and we'll cater it to this year more so as well. But
Mhm.
lots of teams this year are intaking with a claw and then outtaking with another claw. And that type of transfer is often, or that type of subsystem integration is often um, done using something called a handoff. This is what Don't Blink did for the entirety of the season so far, and we might change, but this is what's been working for us. So it's where your claw or intake picks up, passes back, and then your outtake picks up and goes out. Uh, Rishi's laughing at me because my hands got intertwined, but you guys get the gist of it, right? Your claw intake claw picks it up, brings it back, and your outtake goes out. Um, this is one of the most efficient manners in which you can um, transfer. But what will make your transfer as fast as possible is having your outtake like as ready as can be to take from your intaking mechanism. And the way that you do that is by having your outtake only need to complete one action to um, now have the game element, or have two things happen simultaneously that will ultimately take the same amount of time as your outtake making only one action. And Rishi can go into how that works from the programming side now.
Yeah, so I think that definitely is the handoff between two claws is one of the most popular types of transfers.
Yeah.
You'll see it almost on any robot. The only other thing that is probably as popular as this one is transferring from an active intake.
Yeah, but we'll
Which
get into
again,
that
you
later.
go into a outtake, which is a claw. So again, the outtake being a claw is one of the most popular ones.
Yeah.
Um, in terms of what we do is we generally run it through something called a state machine. So like, okay, it's when it's out, right? You press a button and it does the entire transfer sequence automatically. The idea is that you want everything as close and as ready as possible,
Hmm.
and sometimes you might need to add delays between some parts of that transfer mechanism. So for example, the you want the intake claw to be at that position. You want the outtake claw to hold on to the intake, onto the whatever the game element is or the game piece, right? And you want both of them holding on at the same time because you don't want to rely on like, okay, only one has to hold on this. No, that you will start to lose game elements, and that will be devastating during competitions
Yes.
and matches. You want a short period of time where both of them are holding on to the game element, and then you want to let go of the intake, like let go of the game element from the intake, and then just hold it on with the outtake claw or mechanism, and then you want to get the outtake claw ready for the deposit. So all of this sequence, we run it automatically, right? We just have one button, and it does everything it does everything in sequence. And then we also have some escape buttons, so that like in the middle of this transfer, if something were to say go wrong, right, the drivers can just hit an escape button, and it just goes back to the intaking state, ready to pick up another. So let's say it doesn't pick up a sample, we have this intaking state. So I think this will require a lot of optimization, right? So what I would suggest is, you when you have these delays, first set the delays to be like maybe 1.5 second, right? And then
Yeah.
you continuously run it again and again. And there's this great tool called FTC Dashboard. I think we will link it in the description for today, this video. It's very easy to use, and if you can update the values on the fly, right? And that really helps. You don't have to download those. You don't have to like download every time you change a value. The only thing I will say is that like once you know what values you want, you just put them in the code and download them again. Because if the robot restarts, all those values are gone. Just be careful of that, right? So just run the transfer sequence again and again and again and again, like a lot of times, multiple times, right? Like maybe 50, 100 times, and then just keep like changing and reducing delays as much as possible to make sure that um, it's both consistent and as fast as it can be.
Yeah, definitely. So I think if you had to take a couple things from that, the most important part is that you make it so your transfer is safe, so it doesn't fall into your robot, ultimately making you hold on to multiple mechanisms. And secondly, um, secondly, make it so that it doesn't, um, so that, sorry, I got distracted. Oh yeah, and also make it so that you try it over and over again, and like you use FTC dash to make sure your positions are constant and find the best places where you can transfer easily and efficiently. To answer some of the questions in the chat, can you use State Factory to do this and further optimize it? So, Rishi, if you could answer that shortly. We do use State Factory for our tally up, and um, we think it's optimized, but Vikram is always doing this thing, so you never know.
I mean, as I said before, there are many ways to go about this. State machines are definitely one way. I think it's the most popular way to go. State Factory is essentially a tool for to help with state machines, right? I think the most popular way is just a switch case statement with enums and whatnot. But if that might be a little bit, it is a little bit more complicated. State Factory does like put it all together, but I don't know, if it depends on, yeah, each team, depending on like your experience with that library. That's the case with everything in FTC. It's like, okay, if you like the library, you can use it. If you think that it doesn't really fit well with your code structure or work well with your current robot, then you look for other paths. And I will say that the same thing about State Factory.
Yeah. Um, so to move on to other transferring mechanisms, um, there is transferring from an active intake to an outtake, which is a claw, which is honestly what lots of teams are doing. So um, it can be difficult, but if you are using techniques like maybe a tray in the back or um, cutouts in your intake to best optimize how you are picking up from your active intake, it can make things a lot more easy. So I think the best way to go about using an active intake is having a box at the end or maybe a tray that your element can go into to ensure that your element is always in the same spot. And that's something that's really important for any transfer because you always want to bring your element into the exact same location so you can transfer it consistently every time because you don't want things moving from one part of the robot to the other and then um, making things difficult. Um,
Um, yeah, and as Neil said, I think you want it at one spot. So I think one of the most popular ways of going about that is funneling, right? So what you do is you have an active intake, and you make sure that the active, like, because the entire point is that you want to reduce um, the amount of work that the drivers have to do, right? That's the entire point, right? They just have to be there to like just
yeah,
direct the robot, do minimal work, and still get the most amount of points. That is sort of the end goal with any team, right? And that's how you should aim to be as well. So that's why when it comes to like active intake, I think one of the most popular like designs is you build something where it has a large margin for error, which means that you can like it can be anywhere, right? You want to be able to cover a large area in front of that active intake and still be able to pick up. Okay. And the issue with that is when you pick up from such a large area, it might end up anywhere in that active intake, right? So like you build a big box and you put like spinners, right? And it sort of can end up anywhere in that box. For example, like this year's the samples, right? They can end up anywhere in that entire box, right? So what we do or what teams generally do is they sort of funnel, right? And from a large space, they sort of bring it down into one small constrained place that the game element could be in. And that sort of generally always ensures that the game element will be in a certain orientation, right? And you can put sensors there to make sure that okay, is the do we have the game element, right? So it's really nice to always like sort of bring it to one place. And it's also really helpful to make the transfer more consistent. So I would say that that's definitely a way to go. And when you want to make sure that like in the funneled place or whatever the end place that it ends up is should be a little bit exposed and exposed enough where the outtake claw, right, can come down and pick it up, or like you throw it into the outtake claw. That's the other way it could go as well.
yeah. So you'll kind of see this strategy everywhere, but in different ways. So some teams will um, bring their game element or sample for this year into a tray, or they will keep it in a box behind their intake, or they'll even like move it from one place, put it into a little platform, and then pick it up from there. That's something that Wolfpack did during Power Play. They picked up their cone, placed it on a little um, like
Like a
what
tray,
would you
yeah.
call it?
It's
I
like a
wouldn't call it a
plate.
tray, but a little
It's like
plate,
a
and
yeah.
the outtake arm or claw was there ready to pick it up right away. So we suggest doing something that will create consistency, something that will ensure that your element is in the same location every time, so that you know your outtake arm will pick it up. So some things that you can do to make your transfer more and more consistent are adding funnels, adding hard stops to your mechanism. So if your intake is moving upwards, you want a hard stop to make sure that it goes to the exact location every time. And you can add this to literally everything, right? You can add it to your outtake, you can add it to your slides or your vertical extension. And you want to do this just to make sure that you're always remaining constant. Um, and to talk a little bit more about the benefits that come with having a transfer. Hey guys, let's relax in the chat, okay? Um, so some of the benefits of having a transfer are the fact that you're able to intake something else while outtaking. So, for example, what some teams are doing this season is they're depositing a specimen out the front during autonomous and going into intake the next element and that makes them a lot faster and it saves time for them as well. A transferless system wouldn't allow for that. Transferless is where your claw is acting both as an intake and as an outtake. So when you have this mechanism, you're not able to do two things at once. And this ability to like kind of multitask makes your robot a lot more efficient and it makes it so that you can score much quicker. So like having a transfer system allows you to pre-extend, for example, something that me and my other driver Arnav do a lot is place a specimen on the rungs and then pre-extend to pick the next one up. And this is really helpful because it just makes our game so much faster and it allows us to score more specimens in the end.
Mm-hmm. And to address one of the questions in the chat is how do I plan out transfer on my robot? So I think one of the first ways you go is like to CAD it, right? I think it's a great idea to CAD. I mean, I know this wasn't possible maybe 30, 40 years ago, but now it's like really amazing, right? Where you can really
Mm.
visualize it beforehand in the 3D space. It's absolutely amazing. I don't think a lot of teams take advantage of the ability to CAD as well, right? I know there are many free websites online or like many free applications online, such as like you can use like I think we use like Onshape, but there's many that you can use. And like when you constrain everything, I believe that you can sort of move mechanisms around and put the game element and take it through step by step, right? So that's the first step that you want to go about it. And the next step you want to go like whether you're using a custom or even a commercial parts, right? Or like COTS parts or anything, right? You always want to CAD, okay? And the next step is to like actually like do a little bit of prototyping. So like just like get some quick COTS parts or like quick like cardboard, right? Some maybe if you have access to 3D printers, just like get something printed, right? And just like test out a little bit of the transfer, see if like if it's feasible or like how many places something can go wrong. You always want to know how many places it could go wrong, okay? Because you want to reduce that number as much because like in competition, I always like to go by the Murphy's laws, right? Which is like if anything that can go wrong will go wrong. So you want to always reduce that the possibilities of failure, the points of failure on any mechanism, not only the transfer, right? So, but the transfer is one of the more complicated ones. So
And
that's why
it's the one that is most likely to fail
it's
because
most likely to fail. I agree.
you're integrating two mechanisms together and they have to work completely cohesively. And if one fails, then the whole transfer mechanism and your entire robot isn't going to work. So it's incredibly important to make it so that your transfer is as consistent as possible. And if you're a rookie team, it's okay to sacrifice a little bit of speed in the beginning on your transfer. So something that lots of teams would do is maybe bring their block here and then go down and then pick. And this is like obviously slower than going here and your claw's already ready to pick and then just grabs and goes, right? Um, some teams are doing that, but if you are a rookie team and you don't necessarily know the best way to transfer, maybe that's how you should start off, right?
Yeah.
It's important to just get a start on it and then maybe you can make it faster as you go.
Yeah, so always prototype. That's
And
like
always
that's the first
prototype and
step.
always prioritize consistency over speed when you're just starting. And then once you get more of a hang of it, head right into the speed, right? It makes it so much more fun and it'll make you guys way more competitive too.
Mhm. Yeah, definitely. Yeah, and then once you find out like all the points of failure, then you can like get a final design, right? Even the final design, you might have to tweak it, right? Like once you have everything built, right, everything fabricated or whatever, there's always places where you have to tweak it, right? And it's in engineering, nothing is final, okay?
Yeah.
It's
So
the unfortunate, it's the unfortunate reality, but it's sort of how things work.
yeah. So there's some actually really good questions in the chat. Um, my robot erupted into flames due to state factory. Any tips? Unfortunately, no. That's not one of the questions, but I think I just had to say it out loud just to let, yeah, just to bring it up. Okay, so is it okay for your transfer to be based or relying on gravity? So this is a really good question, and um, is important to note. So when you base your transfer on gravity, you're kind of adding like something that you're going to have to wait for. So this is something that will also make your transfer slower if it's not happening while your intake might be rotating backwards, which is kind of what we've been doing. So um, when you are transferring with gravity, it can make things just like a lot slower. But I think if you optimize it correctly, it can work. It's just not really good to do things based on gravity because you have to wait for something. So if you can go right into it, then you can go a lot faster. Okay, there's another question. What's the ups and downs on a transfer system versus a pitch system? So when you say that, I think you mean uh, pitching slides versus having two separate mechanisms for your horizontal and vertical extension.
Yeah,
So
so
yeah,
I think many teams are going for this archetype of pivot slides this year, right? I think that's one of the more famous ones, and we sort of mentioned the advantages and disadvantages of transfer
yeah,
for especially for this year. I think one of the main ones that you'll realize is that okay, so first you cannot multitask, so that like as you're depositing, you can't intake,
yeah,
right? And I know that you're not allowed to control two, but in the time that the pivot slides sort of like retract and then pivot downwards and extend to get ready to intake, you already have something ready to like just start like
exactly.
intaking this sample. That's one. And the other thing that I think not many people will talk about is that when you have a transfer system, right, you can design your outtake specifically for dropping or for depositing, for scoring. And you
Yeah,
can design your intake subsystem specifically to like grab elements, right? And that because one mechanism doing multiple things is a little bit harder, right?
and
To do
it means you have to design it for both activities, and that can
both. Yeah,
oftentimes make it worse for one of them than it could be if it was just solely doing one thing.
yeah. So
So
when you
yeah,
specifically like keep the functionality
yeah,
or
that's a great
only
point.
one functionality in mind, right? Then you can build a much better system, in my opinion. And I
Yes,
think
I
that's true
completely
in a
agree.
lot of cases as well. So
Yeah. I hope that answered your question. Okay. My operator literally quit because of state factory lag. Okay. So how do I integrate a V4B or any other 4-bar into my subsystems? So I think this is a good question too because oftentimes teams like to use different types of ARM systems or different types of intake slash outtake mechanisms to achieve their goals. And something that's important to note is that using a V4B can oftentimes be really helpful because you might only need one specific type of motion, but I would make sure to note that using a V4B can oftentimes be a little bit um, it can make you reliant on only one type of movement, and sometimes that movement isn't necessarily exactly what you need. And this is something that Don't Blink actually had to deal with in the beginning of the season too, where we used a V4B for our wrist movement on our intake arm, and we thought, oh yeah, so smart. We're getting rid of like one more servo, and we thought, okay, we're getting rid of weight. We're making it a lot simpler, but in the end, having a V4B made it very difficult for us to um, like customize the way our robot moved. And this was really difficult for different positions. So let's say we wanted a different position for our um, specimen pickup versus our sample pickup, right? That made it so that, or V4B made it so that was impossible. We had to pick it up in the same way in both orientations. And then also, because your wrist is moving with your arm, it will look like this before you pick up, and it will come down like this when you move your arm down. But that will make it a little bit difficult for the drivers to understand, okay, is it actually going to go on top of the block or not, right?
Yeah, and I think the other thing is that it's I think some if you use some more pulley and belt systems, you will risk sometimes that it skips. So that's definitely an issue that teams come across. And the other thing is that like if you're a rookie team, calculating the pulley sizes and the belt sizes will be a hassle, right? It is difficult to understand. It's difficult to get used to, right? But like there are many tools online. There are many websites online. Like it's like if you really want to just like go into the season like and get something working quickly, right? Then it's definitely not the way to go. It's better to like it's better to not have as many servos or motors if possible, right? You always want to keep it simple, but like don't complicate it by trying to oversimplify. And
Yes, that's
that's
a good way to
something
put
that
it.
a lot of teams and even people tend to miss.
Yeah. Um, but to actually answer your question instead of making you go away from V4Bs, because V4Bs are good, they just need to be used properly, right? So something that some teams did in center stage was uh, intake pixels into that 60-degree angle and then outtake them at that same angle so that they could always be in line with the backdrop. Something that a couple teams during um, power play did. I think one team was cruise control and another team was roboctopi. Correct me if I'm wrong, but I think they picked up their um, cones like this and then they dropped them on the other side of their arm like this again, and they always kept that parallel motion, and having it be parallel at all times was really nice for them. So it worked out well.
Yeah, so any type of four bar for that matter, not even like V4B, any
Yeah.
like any type
100%.
of four bar, those are really nice mechanisms where like you can keep it in the same orientation, or if you change the ratio of the two pulleys at the ends, right, for V4B, then or even for like a DR4B, if you change the ratio of the gears, then you can like control the orientation of whatever you're trying to move, right? And that definitely comes into use, like especially for certain games. Like again, as Neil said last year, you want to go from of something like vertical or horizontal to an angle on the a backdrop, and like in power play, you want to like always keep it um you always want to keep it like parallel to the ground, the cone, right? You
Yeah.
always want to keep it in
But
one
some
orientation for
something
easy.
that's something that's actually important to note is that both of those teams were transferless teams, and they did not use an intake and an outtake. They used their intake as an outtake as well. And I wanna show you guys that a transfer system is oftentimes better because in that game, being able to extend to pick up the next element was incredibly important for your cycle times and filling up the entire field and auto, right? Being able to pick the next element while depositing was really helpful. Like for example, Wolfpack, they had like the most iconic um, middle high pull auto in power play, where they would extend all the way to pick up the next cone and then drop it on that middle pole. And that wouldn't have been possible if they didn't have a um, intake and outtake mechanism. So I think that pretty much covers everything, right, Rishi? Do you think there are any other transfer tips and tricks?
I mean, not in terms of transfer, but since we're on the topic of subsystem integration, there's one more thing I want to talk, especially from like the the software perspective is you so one of the issues that many teams encounter, right, is battery voltage drops. And
Mm-hmm.
on a serious note, I think like we should discuss this. So when you run multiple subsystems at once, right? Like you may have four motors for drive base, and then like maybe two motors for lift, one motor intake, and whatnot, right? And this, right? Like when you start like running a bunch of motors at the same time, or a bunch of like like it tends to start to like deplete the battery, or you'll have many issues with the battery. It's usually a good rule of thumb to like you know drive two subsystems, around one to two subsystems at a time. So
Yeah.
just keep that in mind. Like battery voltage issues are a real thing, and they can really affect your competition, or your like robot's efficiency during a match.
Yeah. I think the best way to attack this is just moving like less than three servos at a time, less than two servos at a time, and like the less things you're moving at a time will just make it like a lot less, like make your voltage drops happen less frequently. So that's really important. So one question that was sent in the chat because someone really wants me to answer their question, I just gotta find it. I think he was asking us about um, our our transfer consistency. Um, our transfer has been pretty consistent this season. We are kind of doing a handoff mechanism. Um, I think if we switch to an active intake, it'll change, and I think it will definitely be different. But so far, we've been pretty consistent. It's been working pretty well. So I think it really just comes down to how you do it and if you can do it well. Um,
Yeah.
okay, I think I think we're good for today's session. Um, are there any last questions in the chat? By the way, the chat is on my phone. So
Guys, you're two guys. You guys really have to calm down. We appreciate the enthusiasm. We love the encouragement. We love the support. But we have to, we have to like keep the end goal in mind, that this is to help teams out there. Like we want to keep questions in the chat more relevant to the current topic, or even in fact any topic about FTC, right? Some
yeah,
relevant, helpful, educative
and hopefully
educative
not troll
questions would be
questions.
nice. Yeah, hopefully. Please, we do love the encouragement. We love the
Okay.
support. Thank you all, but just please,
Yeah,
okay.
I think there are no more questions in the chat. Uh, thank you all for joining. This is Neil from FTC Rookie Rescue, and thank you so much. We will see you next Sunday.
Okay. All right, bye.
Bye. Oh shoot, you couldn't see us waving. Bye.